Good evening, good afternoon, good morning, and welcome to this Marintec Innovation webinar series. I am Michael Duck, a director of Marintec China and Executive Vice President Asia at Informa Markets, based in Hong Kong. I am very pleased to have been involved with this exhibition held biennially in Shanghai since 1994. This webinar today is the first in a series that will hopefully give you the insight into some of the key technology initiatives in the maritime world today. We have signed up for today's session over 1,000 people from all around the world, from many key maritime companies and organizations and associations. The title of today's webinar is The Fourth Industrial Revolution at Sea, Autonomous Ships Overview. To give this paper, it gives me very great pleasure to welcome today Dr. Martin Stopford, an old friend of Marintec China, and as I'm sure you will agree with me, is the foremost economist and thinker in the maritime world today. Greetings, Martin. His books and academic papers have been used by the maritime and finance industry for decades now. He is also the non-executive president of Clarkson Research Services, well known to all on this call. Dr. Martin is also joined by three eminent panelists from the maritime technology world. I welcome them joining us here today. They are from Singapore, Chris Chung, Director of Digital Innovation and Strategic Projects at the Wärtsilä Acceleration Center. Hi, Chris. From Shanghai, Alf Kari Adanes, who heads up ABB Marine and Port Products Group Electric Solutions and is manager for the Hub business line Marine Ports. Hi, Alf. And lastly, also from Shanghai, Mr. Li Xin, Senior Engineer and Vice Director of the Innovation Center, Director of Smart Ship Development at STARI, S-D-A-R-I, the Shanghai Merchant Ship Design and Research Institute, a member of the CSSC group. Hi, Mr. Li. The format of this webinar today will be Dr. Martin's introduction of his recent key thesis on smart shipping, and this will take over 20 minutes. We will then have 20 minutes questions and statements, interaction from the panelists directly with Dr. Martin. After that, in the final 20 minutes, we will take questions from you, the audience. If you do have any questions, please submit them to the Q&A box at the bottom of your screen. Dr. Martin, the floor, or rather the screen, is yours.
Thank you, Michael. I hope you can, just a moment, apologies. There we go, I need to be on the right screen here. Missed it. Right, thank you very much, Michael, for that excellent introduction and for the kind words. And can I just say what a pleasure it is and an honor to be sharing the platform today with three leading technical experts from ABB, Wärtsilä and STARI. I think this is a great chance to debate what I believe is one of the most important topics that we have in front of us today in the shipping industry, the fourth industrial revolution at sea. This is something that it's been around for a long time, but it's crept up on us, and the shipping industry has really not been able to participate because the communications and the technology was not really able to do this. But other industries have. The car industry, recently, The Economist magazine described a BMW as a computer on wheels, I don't think we can say that about cars at the moment, but I hope that our vision is that we can see ships as floating computers, and that we can use the technology available today through the I4 revolution to make people running ships and fleets of ships more effective. And what I'd like to do is to split my comments around 3 points. First of all, the ship itself. We have to look at digital technology on board ship, and I'm going to talk about the integration of functional systems. Then we want to look at the shipping companies and the way that they are organizing their operations through transport management centers. So there's a separate section here where we're looking at the shipping companies as well as the ships and how they're organizing themselves. And then finally, there's digital cargo and the integrated logistics systems, which we've been promised for many years. The shipping industry has not really ever managed to get on top of this, and I hope that through I4 technology we will be able to do this. And so that really is a foresight of what I'm going to talk about. I'm going to split it into 3 parts. The first part of my comments will look at 3 shipbuilding scenarios, 2020 to 2050. These I've taken from a paper I published with Seatrade Marintec quite recently. And it will, I think, lay out the commercial environment in which this new technology will need to be implemented. And there are 2 important issues that come out of these scenarios that I want to talk about. Then secondly, the economic goals of I4 technology, because it is not about putting lots of computer programmers in a box and then writing a system. It's actually about people, programmers and systems people, producing systems alongside the people who are going to operate them on the ship or in the office, so that the systems are user-friendly, secure and robust. And of course, they have to be tested at sea, which is a very important part of the whole process. And then finally, I'll lay out some outline views about how this might actually be done in a ship, a shipping company, and in terms of the logistics. So that's my agenda for the next 15 minutes. Well, if we start with the shipbuilding scenarios, the economic scenarios with which I've developed take account of both the current pandemic, which is global at the moment, and the I4 revolution, and most importantly, climate change, which, although our minds have been on the coronavirus pandemic recently, climate change remains at the top of the agenda for many of us. And I do believe for the shipping industry, it's priority, not just to meet IMO's targets, but to exceed them, and I believe that I4 technology can contribute very substantially to doing this. If we take a look at the shipbuilding industry, this is the historical deliveries of ships in million deadweights, as you can see on the left axis. And shipbuilding has had 2 very big booms in the last 50 years. One was in the early 70s, and a second one was just a few years ago. Ships were in this great boom were being delivered in 2009, 10, 11 and 12. And those ships are now an important part of the world fleet. If we take a look at the scenarios that I've developed, then basically there are 3 there's 3 scenarios here. Scenario 1 assumes that trade grows at 3.2% per annum, which is the 50-year average. If we take the average growth over the last 50 years, it's 3.2%. And I've assumed that the ships operate at their design speed of about 14 knots. And if you do that, then you find this demand scenario where by 2030s, you have another peak of demand, about 230 million deadweight of ships. Scenario 2 looks at slower trade growth, which I believe there's a good case for, because the world economies are changing, maturing, they're changing the sorts of things. There's more to life than producing steel. We're into sort of a lot of things like digital infrastructure nowadays. So this assumes trade grows at 2.2% growth, and the ships operate at 12 knots, which is about the level that we see at the moment. And as you can see on this scenario, the demand goes up to a little under 200 million tons and settles at that level. And then finally, a third scenario assumes that fossil fuels, which account for 40% of our trade today, are trade decline over the next few years. And some of the big trades like iron ore and so forth also decline slightly, or at least don't grow very much. And the fleet operates at 10 knots, which is a high eco speed, in my opinion. It's not unprecedented. And in that case, we still get a boom in 2020. So if we now focus on my two key points here, the first point is that these scenarios show that there will be a dip in the requirement for new ships over the next couple of years. And of course, that is the requirement, it's not the orders. And traditionally what has happened when you have a dip in demand of this, in requirements of this sort, you get counter-cyclical ordering by shipping companies or by governments. And I think one of the things we should focus on here is counter-cyclical ordering, which is linked to ships with new technology. And one of the things I hope the panel is going to discuss is what is on offer at the moment. And the reason this is so important is that the second issue that we have to face up to is that the fleet will need to be replaced in the 2030s. And it would be quite wrong to replace it with old technology ships. By the 2030s, we have to have new generation of ships, I4 digital, ideally with zero carbon propulsion units, so that all of this massive amount of shipbuilding is done with the latest technology, whichever scenario you go for. It's a lot of ships. And so that sets us the target that we must start immediately if we are to meet. It takes years and years to develop digital technology at sea. We must start immediately if we are to have the ships and designs available by the 2030s to meet this requirement. Well, let me move on to the economic goals of the I4 revolution. I'm going to go through this fairly quickly, but there are 2 points I want to make. First of all, I4 development can be used as a better way to manage the functional board systems on board ships. In a sense, today, we're sort of trading blind. We know so little about what really goes on board a ship in real time. People on the spot in the engine room, on deck when you're handling cargo, they know these things, but that information is not shared, it's not recorded. So we need to deal with these systems digitally, and we need to integrate them. That's the big word, integration. Interoperability is a word McKinsey, the consultants, use. These systems must be simple, reliable, and they must add economic value and environmental value. We must never lose sight of these goals when developing them. Now, the ships that we have today, if we look at the potential of I4, the goal, as I've said, is to use digital information and automation to achieve better cost and revenue performance. And there are four things that we can do here. Currently, many of the control systems on board ship are local, and the controls rely on hard wiring. There's a few Ethernets being run out, but most of it is hard wiring. I believe we should be replacing cables, controls with ship control area networks, SCAN, I call it. This is already being done on board in land-based transport equipment like motor cars, and it hasn't been done in ships because it's a more challenging task. They're bigger and more complex, but the opportunity is there to replace wires with messages. And we need to integrate the control systems developed in this way by learning to use the process control systems that are used in land, for example, to run very big, sophisticated chemical plants. And I'm hoping the panel will talk about this a little bit, and automate parts of processes using algorithms where it's safe and viable to do. And so those are the things you do to run the ships. But in addition, I've said we're flying blind. These systems are going to generate an enormous amount of information and record this information so that we can analyze it and use it to plan what is happening in the onboard ship and in the fleet of ships, so that we can get event logging will be automatic. At the moment, people on the ship the managers on the ship spend time filling in forms. That will be history. It will all be done by the information systems. And the performance data, anomaly identification, you collect that data and you use it to start to predict errors that might occur, problems that might occur, and prevent them so that you reduce the mechanical problems on the ship. And that really is the ship, the main goal. The vision is that we use I4 technology to cut costs. The strategy is to use digital technology to automate processes. The method is continuous improvement. You're not going to do all of this at once. You start step at a time to do the things you can do today effectively. You make sure they work at sea. You make sure they give a financial return and a proper environmental impact. And the result is that your quality assurance works well. I'm a real believer in quality assurance. If you can get that to work, you move to a whole level of management. And you make people more productive, and the transport performance improves in ways that you couldn't even begin to imagine. I'm not going to dwell on the next two slides, but I just want to make the point that that we must have clear goals for costs and revenue. And this slide, this equation shows you the areas of costs on a ship which we can address. These are simple things that the people on the ship do every day today automatically. But with the I4 systems, we are going to be able to get these done much more effectively. We will control our operating costs much better. We will lower the propulsion costs by optimizing every aspect of that. Never will a ship go to sea with an engine that isn't totally in balance all the time. If you're running a Formula One engine, Formula One racing car, you balance at 16,000 RPM, you balance every cylinder, every revolution. You know, you can do that for your ship's engine, and that's just a tiny little example. You reduce electricity costs across the whole operating system because you're monitoring them and getting feedback real time. You reduce your cargo handling costs because you have proper information about what's going on. I know this is very challenging and a lot of it is done manually, and maybe, well, that's the challenge, isn't it? Repair and maintenance, and the enormous amount of unplanned maintenance and repairs cause a great deal of cost of time. You'd be amazed when you track ships how much time is lost. This is stuff that can be dealt with by predictive maintenance systems. And of course, we use the assets, the capital assets, far more effectively because there is somebody who is tracking the use of those and the real cost of those assets at any point in time. That is the cost side. And on the revenue side, you know, ships spend only a small proportion of their time loaded at sea. And once you really know what's going on, you cut out unplanned maintenance, you optimize performance, you get together with the charterers to integrate arrival dates so that you're not arriving and waiting, and you get confidence in the system that you can do that. You don't need to arrive early in case something breaks down. And you fill your ships properly and use their dead weight as much as you possibly can. And of course, you get the right freight rate, because you get a better freight rate because you're offering a better service. Now, I hear every time I give this lecture, somebody says the charterers won't pay. We have to get closer to the charterers. They have to be part of this whole process. They need to be coming back into the process and maybe giving 7-year time charters on new ships which have new technology, which they are a stakeholder in. I think that would be a very, very good way forward as we move into the next generation, especially with this very tough period we have ahead for the shipbuilders. We need cargo back into the equation in shipping. How will we make this work at sea? Well, it's a big story. It's a lot of technology, and I don't want to delay because we've got people on the panel who are much more competent to talk about this than I am. But my vision is this, that this is an outline of a ship, and I've divided the functional systems on the ship into these 8 groups. And under the vision, each of these functional systems is a self-supporting integrated system which communicates with the rest of the ship through an electronic control unit, ECU. And each of these systems has an ECU, and the ECU communicates with the rest of the ship through a backbone operating under control area network, which has protocols which have yet to be agreed. The car industry has protocols called CAN bus F2, that's the latest version. There is a protocol for ships called NMEA 2000. That is for small ships, and it doesn't address a lot of the big problems that have to be addressed. But it is important that if you're going to have a lot of different systems communicating on the ship, you need protocols so that there are standards. And then hopefully this backbone feeds into a process control unit which manages a lot of the operations on the ship, hopefully in just the same way that you might manage a chemical plant on land or something like that. So that's the ship. And then we say, well, what happens with the shipping company? Well, I think you try and run the shipping company as a transport factory. They're not running the ships. We've got groups of people running the ships through their process control operations teams, and they communicate with the company transport management center, which is set up and designed to operate a fleet of ships as though it was maybe a chemical plant. It's each of these is a process delivering cargo, and we have commercial elements in this system, and we have the much bigger operating systems than you have in existing companies. I mean, the average bulk shipping company has only 1 or 2 people per ship in the office. I think we're going to have to spend more money here, and we hope we get it back by running a more efficient system. And finally, we bring in the most important people of all, our customers, and we start to integrate them through the commercial side and the systems side. They are integrated. We integrate with the ports. The equipment suppliers are linked into the shipboard systems and working with the onboard control teams on the ships. And hopefully we go right through transport, and we have business to business transport systems, which is the great objective. And all of this is monitored, so that my vision is that when this gentleman comes in the morning and it switches on his computer, he sees the carbon footprint of his fleet yesterday, this week, the trend, the performance of each ship, any anomalies against performance, all of this, and that is the best way to improve performance. Short of a zero carbon propulsion system, that's the way you do it. And on that note, I'd like to say thank you very much for your attention, and I would just finally just remind you that Rome wasn't built in a day. These systems won't appear immediately. We're going to have to do it in waves of technology, and the first wave will be diesel engines. The second wave will be gas and hybrid electric technology. And the third wave is the fuel cell. And the important thing here is that in each wave, we are building the platform which will eventually be available for fuel cells, the all-electric ship, because with diesel engines, we start to build the I4 technology platform. Then we bring in gas and hybrid. We learn to use cryogenic fuels, and we learn to develop electrical onboard systems operating the gas-powered engine and the electric batteries, and then finally the fuel cell. And once that's done, we should be ready to go, and we should be able to meet those objectives we've been set by IMO, and hopefully we'll be proud to be members of a business which is leading the world in digital technology. Thank you very much for your attention, and on that, to pass the back to Michael Duck and end my slideshow. If I can just get back off my screen. There we go.